Okay, so let's start with the assignment. In the last class, we have covered one or two question, I think, of the assignment. Now we'll cover the rest of the question. So basically, this is the semicircle based question. Okay, so semicircle based question may, if they'll ask you the RMS value, then in that case, that would be root 2 by 3 multiplied by I maximum. ठीक है, तो it's better to remember this formula क्योंकि we'll have long derivation for this, वो तुम्हें याद नहीं रहेगी. And this kind of question paper has been never asked in your midterm or in end term in Manipal. ठीक है, तो ये पूछते भी नहीं है, they give it in the assignment only. So I'll suggest you to do better, remember this thing only. Solution I'll send it to you later on. ठीक है, मैं इसका solution भेज दूंगी if you want. But now for being, you need to learn this formula that IRMS is equal to root 2 by 3 into Imax. Okay. So they said if the maximum value of the semicircular current is 42 ampere, so we need to calculate RMS value. So we can simply multiply and then we can get the value for RMS. ठीक है? Now after this, the next question, question number 4, if the maximum value of semicircular current is 25 ampere, so from this maximum value we can get the RMS value, right? By using the formula root 2 by 3 multiplied by maximum value, that is 25, right? तो यहाँ से हमारे पास RMS value, we got it. And if this current passes through a resistor is how much? 30 ohm. So as you know, the formula of VRMS is equal to IRMS into R. So IRMS we can obtain from here. Resistance they have given as 30 ohm. Then we can calculate the voltage drop across resistor. ठीक है? That would be the voltage. Clear? Now problem number 1, question number 1. See, this is the graph. They given the value of A and B and they are asking the average value of current. तो पूरा इस ग्राफ को सॉल्व करके I'll tell you the formula. I average is equal to 1 by B into 2 of B. B से B cancel, answer would be 2. तो A की value and B की value, if anything is given, answer here is 2. Okay. Now I'll tell you how will obtain this. ठीक है, वो मैं बता रही हूँ how will we get this. See, basically we'll have formula for I average. What is the formula for I average and what is the formula for IRMS? There is a fixed standard formula for IRMS and I average. So write down this formula. I average is equal to limit vary from 0 to जितना भी तुम्हें दिया हुआ है, then in that case divided by the base length. Base length क्या होता है basically? Like suppose we'll have this kind of circuit. एक minute. Now see, इसका formula क्या होता है? We'll have I average is equal to alpha 1 to alpha 2 I of dt divided by the base length, and IRMS का formula is root of limit vary from alpha 1 to alpha 2 I square dt divided by the base length. Okay, now see what is basically a base length. We'll have two types of waveform. ठीक है, one is the symmetrical waveform. This one is the symmetrical waveform. Symmetrical means कि we'll have the output in the positive side also and we'll have the output of the negative. Like suppose this is 0, 1, 2. तो हमारे पास यहाँ से यहाँ तक भी output आ रही है and यहाँ से यहाँ तक भी output आ रही है. Another kind of waveform we'll have as asymmetrical. Asymmetrical means कि हमारे पास यहाँ से यहाँ तक आउटपुट आ रही है, देन 0 है और उसके बाद अगेन सेम आउटपुट आ रही है. सो दिस इज द फॉर्म ऑफ asymmetrical. ठीक है, समझ गए ये चीज? टेल मी कि if we'll have both the output की positive side पे भी और negative side पे भी, that would be symmetrical. If we'll have the output only the positive side, that is asymmetrical. Clear? So now in this case 0, 1, 2. Now the thing is we need to calculate base length for both the cases. बेस लेंथ फॉर दिस पर्टिकुलर केसेस कि हम सिर्फ 0 से 1 तक की आउटपुट लेंगे क्योंकि आगे हमारी सिमेट्री में जा रही है. तो बेस लेंथ ओवर हेयर इज 1 माइनस 0 दैट इज इक्वल टू 1. बट फॉर दिस पर्टिकुलर केस हम बेस लेंथ पूरा 2 तक लेंगे, 0 से लेकर 2 तक, बिकॉज हमारी कंप्लीट वेवफॉर्म ये है. सो फॉर दिस पर्टिकुलर केस द बेस लेंथ इज इक्वल टू 2 माइनस 0 दैट इज इक्वल टू 2. डिफरेंस समझ में आया दोनों के केस में? फर्स्ट केस में बेस लेंथ इज 1 एंड सेकंड केस में बेस लेंथ इज 2, क्योंकि यहाँ पे हम आउटपुट सिर्फ पॉजिटिव साइकिल की ले रहे हैं और यहाँ पे हम आउटपुट दोनों साइकिल की ले रहे हैं, पॉजिटिव भी नेगेटिव भी, बिकॉज एसिमेट्रिकल है. गॉट इट? क्लियर दिस थिंग? टेल मी फर्स्ट. So this would be a symmetrical waveform. Okay, so now for this particular case, if I'll calculate the average, so tell me I average का formula is I average is equal to 1 over base length. So in this case, as you know, what we need basically base length. So how much is the base length over here? कहाँ से कहाँ तक आउटपुट आ रही है? 0 से लेकर b तक. So in this case base length is how much? b minus 0, that is equal to b. Correct? Now basically we need to get the value for alpha 1 and alpha 2. Like तुम्हारी आउटपुट कहाँ से आ रही है? 0 से 1 तक. So in this particular case limit will vary from 0 to 1. Right? As I told you कि symmetrical case में we have to take output for this particular green waveform. अब यहाँ पे देखो तुम्हारी आउटपुट कहाँ से कहाँ तक जा रही है? 0 से लेकर b तक जा रही है. So integration limits would be from 0 to b. Correct? Now after that what we need over here? I की वैल्यू क्या होगी? Now ध्यान से देखना I की वैल्यू क्या होगी? This is a right angle triangle. Yes or no? तो right angle triangle में we can write down as tan theta. Tan theta is p by b. इसके बहुत सारे methods होते हैं. I'll tell you the simple method. Perpendicular over here is current and basically perpendicular क्या है यहाँ पे? Current and the base is time. Right? So basically can we say that tan theta is equal to p by b is equal to I by t? Time is 1 second over here. Suppose I current is 5 ampere, so I is equal to 5. So can we say that I is equal to 5t? हमारे पास ये इक्वेशन आ गई that will have I is equal to 5t from here. Now see, for this particular case it is basically divided into two categories. One is the triangular waveform and another one is this square kind of waveform. ठीक है? First of all I am telling you for the triangular waveform. For the triangular waveform we need to calculate I of t, है ना? So I of t is how much? Again we'll write it down the same way. Tan theta is equal to perpendicular over base. Here the perpendicular is I, that is current, because this is the current waveform. Base over here is t. Correct? Here particular for the green color, current is how much? 4. So I'll write down 4 and time is how much up to here? That is a. So I write down a. So from here what we can conclude that I is equal to 4 by a t. Yes or no? Tell me. So from here we'll get the value for I. Right? Now see what is left. We already know base length. We already know limits. We already get it I. Now we just need to put it down the values. First of all tell me any doubt up to here, because I want to make you understood. This kind of problem will definitely come in your exam, in midterm or maybe in end term. Okay, so I'm redrawing it and I'm telling you from the very basic. Like suppose we need to calculate I average, and I average formula is varying from limit alpha 1 to IDT over base length, right? So limit कहाँ से कहाँ तक जा रही है, 0 to b I I of t. Now base length is how much, b minus 0, so that would be b. So b minus 0 is b only, so I'm taking outside 1 by b, limit vary from 0 to b I of t dt, right? After this, what you need to do basically, you need to divide this into two parts, okay? Green wala and yellow wala. So that would be 1 by b outside. Now green wale part में 0 to a will take I of t dt, plus yellow wala part will take, then that would be from कहाँ से कहाँ तक वेरी कर रहा है, a to b I of t dt, bracket close, right? Then after that 1 by b, limit vary from 0 to a I of t. For the triangular waveform we already calculated that, we got it as 4 by a t, right? So for this particular case we got it as 4 by a t. So 4 by a t, market this is very important because एक क्वेश्चन तुम्हारा पेपर में पक्का आता है. Again a to b. Now can you tell me how much is the value from a to b? That is fixed. कितनी आ रही है? 2 ampere. At a point also it's 2 ampere and at b point also it's 2 ampere. So we can simply write it down as 2 dt. Okay. Now we need to solve it further. That would be 1 by b, 4 by a, t square by 2, limit vary from 0 to a, 2 integration would be 2t, and limit vary from a to b, bracket close, right? Then after that 1 by b, 4 by a multiplied by, after putting the limits we'll get this thing, a square by 2 minus 0 plus 2 into something will get it. Okay, I'm not doing complete, but finally what will get it as 1 by b 2a plus 2 of b minus a. If we'll solve it, we'll get 1 by b into 2b, and the answer final is 2 ampere. So average current basically we get it as 2 ampere. अब a और b की कोई भी values तुम्हें दी हुई हैं for the different questions, the answer would be simply only. Okay, now see in the next problem, question number 2 I think. Yeah, in the question number 2 they ask you to calculate IRMS. So IRMS ka formula, again I'm telling you from the very starting, just see the formula. Basic formula for this one is limit vary from alpha 1 to alpha 2 I square dt over base length, right? So I told you all the values. Again I'm solving this complete, the square root also. That square root limit vary from how much, 0 to b, right? So limit is varying from 0 to b, current I of t ka square dt divided by the base length. Base length is how much, b minus 0, so that would be 1 by b. मैं बाहर ले रही हूँ उसको, ठीक है? Again as I told you we need to divide it into two parts, 0 to a, and then we'll divide it from a to b. So again square root, then 1 by b, limit vary from 0 to a I of t ka square dt plus limit vary from a to b I of t ka square dt. Okay, now after that 1 by b, limit vary from 0 to a. I of t की value we have already calculated by the formula na, tan theta wala, right? So that would be how much? 4 by a t, यही आई थी tan theta से, square dt plus a by b, तो ये 2 आई थी इसकी वैल्यू, तो 2 का स्क्वायर 4 dt, right? ठीक है. Again we need to do complete integration. I am not doing the integration wala part. After solving this complete integration, we'll get the final value for IRMS. This one is important for assignment point of view. That is, we'll get it as 4 by 3 a by b plus 4. I solved it already by myself. So you just need to substitute the value of a and b. After substituting the value of a and b according to your assignment, you will get the value for IRMS. ठीक है, बट हमारे पास ये कहाँ से आएगा? इसको solve करके. How can we solve this question? In this case, we need to calculate total current. So I total would be I1, that is the vector addition basically, plus I2 plus I3 plus I4. Right? So magnitude of the total current is how much? That I total is equal to root of I1 का square plus I2 का square plus I3 का square plus I4 का square. Right? So all you are having different values of I1, I2, I3. You can substitute the value 16, 11, 10 and they don't give you अच्छा x की value they have given you separately ना, so you can substitute the value and then you will get the magnitude, right? And then they'll ask you the angle का formula is theta, so theta is basically tan inverse I total divided by I1. I total तुम्हारे पास ऊपर से आ जाएगा, यहाँ से आ जाएगा, then divided by I1 because I1 से start हो रहा है and it moves basically angle measured from anti-clockwise. ठीक है, so this is how you can get the magnitude and the theta. यही पूछा होगा I think. Wait, let me check. This is first question they ask you the magnitude, that is I total. Another question they ask you the phase angle. As they have mentioned, if the magnitude of current phasor is 11 ampere, then you need to calculate the phase angle. ठीक है, understood? हो जाएगा. 16 का square plus 11 का square plus 10 का square plus x का square. Then you will get the value and theta would be equal to this one divided by x. Okay. If you have any doubts in the assignment, or the previous assignment, then you can contact me on this particular number that is showing. And if you want any doubt class, then also you can contact me. And if you want notes or PYQs, then also you can contact me. And if you want coaching of this subject, or if you are having makeup makeup exam for BET or for BE or for physics and maths, okay, any subject, then also you can call me or contact me on this number. Thank you. Bye bye.